Last lesson, 8.4, factoring out the greatest common factor. All right, so let's start by doing a quick review. This was like, when was this? This was like 8.2, I think, when we were to distribute, or maybe that was 8.1. Okay, so distributing. Let's do this, take a minute and pause and try and do these problems, A, B, C, and D. All right, so if we distribute, we can distribute numbers. So something like that, 8 times 2 is 16, and then 8 times 5 gives us 40. Okay, so that's one way we can distribute numbers. We also learned that we can distribute variables. So y squared times 2, or times 2y squared will end up giving us 2y to the fourth. So again, if we're multiplying like bases, we're going to add those exponents. And then y squared times negative y, and that's like y to the 1, so that would give us negative y to the third. Okay, and then we learned how to do it with numbers and variables. So we kind of treat them separately. So 6 times 7 is 42, and r times r squared will give us r to the third. And then we'll do 6 times negative 5, that gives us negative 30, and r times r is r squared. And then we did something like 6 times 3 gives you 18, and r, that's all we have is just one r. Okay, and then we could even have like exponents. We can distribute numbers, variables, and exponents. So something like that could give us 12, and then x squared times x gives us x to the third. And then we'll do it to the negative 10, so that's negative 20, x squared. Okay, so what we just did, again, that's distributing. What we did to do that is we multiplied. Okay, so while using the distributive property, we must multiply the outside number or variable by all of the terms in the parentheses. So does it make sense that if we want to do it backwards, if we want to take those numbers out, then we would divide, okay, all of the terms by the greatest common factor. So if you want to take the greatest common factor out, you'll also need to divide every term by the greatest common factor. So let's do an example. Again, we're going to kind of follow the same sort of thing. We'll talk about coefficients, then we'll do variables, and all that stuff, okay? So first, let's identify the greatest common factor. What can we divide 10 and 30 by? Okay, and you'd probably say 10, okay? If a number ends with a 0, then we can divide it by 10. So if we take our greatest common factor, we'll put it over here. But then we want to say what is left. Okay, if we take a 10 out, what's left? And to do that, we need to divide everything by 10. So 10 divided by 10 would give us 1. And then we have negative 30 divided by 10 gives us a negative 3. So this is called factoring out the greatest common factor. We took out that greatest common factor, we factored it out, we pulled it out of our expression, and then what's left, we leave it in a parenthesis. So we did something similar here, just backwards. Here we distribute the 8, okay, by multiplying. To factor out the greatest common factor, we'll need to divide out the greatest common factor. Let's try another example. So again, we're just looking at the numbers right now. What's the greatest common factor for the numbers? What can we divide 6 and 12 by? Well, I know that 2 goes into 6 and 12, but is it the greatest? No. 3 goes into 6 and 12, but that's not the greatest. 6 goes into 6 and 12, so you could do it. The greatest common factor should be 6. And then we'll need to divide everything by that greatest common factor so that we know what's left. So 6 divided by 6 is 1. So like 1p squared, or just p squared if you want to call it that. And then 12 divided by 6 is 2. one way you can always check is take out the greatest common factor, divide it by that greatest common factor, and when we look at what's left in that parenthesis, is there anything else we could divide 1 and 2 by besides 1? And there's not, so that means we've got it, okay? Say you said the greatest common factor was 2, and you divided all of these by 2, you would end up getting 3p squared plus 6. And then we could look at that and say, ooh, I think I made a mistake. I think I can still divide these by 3. So either you can start all over, or you could factor out a 3 and know that we already have a 2. And then we could do our p squared plus 2, and that would give us 6. So if you make a mistake, not all is lost. You can just continue factoring things out or start all over. All right, try C and D by yourself. So hopefully you gave that a try. What's the greatest common factor for the numbers? Looks like maybe a 2. Okay, 2 goes into 6. Again, it also helps to just look at the smallest number. So 2 goes into 6, 3 goes into 6, but 3 doesn't go into 8 or 14. 6 goes into 6, but 6 doesn't go into 8 or 14. So it's got to be 2. Our greatest common factor has got to be 2. So we'll take our greatest common factor out in the front like that, and then we need to make sure we write down what's left. So we'll divide everything by 2. We'll get 4n squared plus 7n minus 3. And then for D, again, we look at the greatest common factor. Maybe the smallest, we can look at 10. Does 10 go into 25? Nope. What about 5? Does 5 go into all of those? Yep. So we could divide all of them by 5. 10 divided by 5 is 2. 25 divided by 5 is 5. And negative 20 divided by 5 is negative 4. Okay, so that is factoring out the greatest common factor for the coefficients, for numbers. Okay, now let's talk about variables. So we're going to do a quick review on the quotient rule, because we're going to end up dividing variables, and we need to remember what that does. Okay, so when we're dividing like bases, we subtract their exponents. So if we have x squared divided by x to the 1, okay, another way you could say this is like x times x over x, and they cancel. Or you can think of it as x to the 2 minus 1 gives you x, okay? So when we're dividing like bases, we'll subtract, and we're going to do this here in a moment. We'll probably save the rest of those. If you want to practice those, you can. Or maybe we should do C, okay? So here, again, we want to simplify our fractions, our coefficients, just like we normally would. So 6 divided by 2 gives you 3. And then we have y to the 4th over y to the 3. That's 4 minus 3 gives you 1. All right, so we'll do some more examples like doing the problems. Okay, so first, we're only going to focus on the variables right now, so don't worry so much about the numbers. How many x's can we take out? Or what's the smallest or the largest amount we can from each of those? So you may say, well, I can take 3 x's from here. But you can't because there's not 3 to take, there's only 2. So the smallest exponent is 2, which means we can take out an x squared. Which means if we're going to factor it out, we need to divide everything by 2. And this is where this comes into play, the whole dividing exponents, or dividing bases with exponents. So we have 10. If you wanted to put a 1 there, you can. So 10 divided by 1 is just 10. And then x to the 3 divided by x to the 2, again, we subtract those exponents, so that leaves us with an x to the 1, or just x. And then we'll do it for the other one. So 3 divided by 1 is 3. and then x to the 2 divided by x to the 2, well, that just cancels, and that's what we'd end up getting. Nice thing about this is you can always distribute it back and make sure you got it right. All right, give B and C a try. All right, greatest common factor for the variables. Again, it's going to be your smallest. This is not in standard form. Okay, now it is. So we look at the variables. The smallest amount is x to the 5th. We can take 5 x's from both of those terms. So we'll have x to the 5th. One other thing is we have a leading negative, which we'll talk about that. I don't think I meant to have it be like that, but we can do that now. So we have a leading negative, so that's part of your greatest common factor. And now we'll need to divide everything by negative x squared. And we'll write down what's left. So we have a negative 5 divided by a negative 1. So that gives us a positive 5. And then, sorry, this is a 5. That did not look like a 5. And then we'll do x to the 8th over x to the 5. Again, we subtract, so that leaves us with x to the 3. And then for the next term, we have 8 divided by negative 1 gives us a negative 8. And then the x to the 5th cancel. All right, here's one last example. It's in standard form, check. Total, the highest amount of variables we can take out is a to the 4. And then we'll need to divide everything by a to the 4. So again, we subtract their exponents. So that gives us 8 to the, we'll do 8 minus 4, gives you 4. 6 minus 4 gives you 2. And then those cancel out. Okay, but we still have that 15. All right, so that is the rules with like the exponents. Okay, just remember when the leading coefficient of a polynomial is negative, it is part, the greatest common factor is also negative. Okay, so we kind of talked about that here for B. Sorry, sometimes I feel like I don't think about it, but this is probably like going all over the place, like your screen is like crazy. I hope you don't ever get like nauseous or anything. So greatest common factor here, if we look at the numbers, it looks like we could divide all of those by a 4. We have this leading negative. For the variables, we can't take any x's out because there's no x's to take from the second term. So then we'll just divide everything by a negative 4. And what's left will give us a positive 3. So negative 12 divided by negative 4 is 3. X to the 7th. And then 4 divided by a negative 4 gives us a negative 1. Right? Okay. That's probably good enough for that since we've had 2 examples of that. Let's just bring it all together. We don't need to do all of these problems. Why don't we just do 3 of them? If you feel like you've already got it, then you can just start working on your homework. All right? Well, just do a couple of these with me. Okay, because you got to check all of them. You got to check off the 3 things: numbers, variables, and the sign. So looking here, we look at the numbers. It looks like we could divide all of them by 3. For the variables, we can take an x from both of those. So that means we need to divide everything by 3x. So 15 divided by 3 is 5. We have x squared over x. That leaves us with 1x. And then on the right side, negative 3 divided by 3 is a negative 1. And x divided by x, those cancel, or it's equal to 1. So 1 times 1. So, all right. How about... let's do F. So it's in standard form, check. What can we divide 2, 16, and 8 by? 2. We have a leading negative. And then how many m's can we take out? Well, the smallest amount would, or the smallest exponent. So we can take 2 from each of those. so m squared. So we need to divide all of these by negative 2m squared. So negative 2 divided by negative 2 is a positive 1. 4 minus 2 is 2. 16 divided by negative 2 gives us a negative 8. 3 minus 2 is 1. And then we have negative 8 divided by negative 2 gives us a positive 4. And m squared divided by m squared cancel. Okay. I also want to add one here. Maybe we'll say plus 2. No, let's do plus 10. Okay. So we look at these, we look at the numbers. Looks like we could divide all of those by 5. For the variables, here we have a constant, which means there's no variables to take from there. So we can't take out any of the k's, and we don't have a leading negative. So all we need to do is divide everything by 5. So that's 3k to the 7th minus 4k to the 5th minus 1k to the 4th plus 2. Okay, so I just want another example of when we can't take out a variable. And then maybe this one. So here we have a leading negative. This is in standard form, so we have a leading negative. It looks like we could divide all of those by 4. So this one's tricky because you could probably think 2, but 4 would be your greatest common factor. And then the smallest amount, or the total, the most amount of x's we can take is x. Divide everything by negative 4x. Okay, so negative 16 divided by negative 4 is 4. We have 3 minus 1 gives us x2. 12 divided by negative 4 gives us a negative 3. And then we have 2 minus 1 gives us x to the 1. And then 20 divided by negative 4 gives us a negative 5. And we have x over x, those cancel. All right, so that is factoring out the greatest common factor. So just make sure when you do your homework and like when we do our review, make sure you read the instructions, because sometimes it may just ask you to write down the greatest common factor, and sometimes it will ask you to factor out the greatest common factor. Okay, all right, we'll see you. Let me know if you have any questions.